So today's video we're looking at the quadratic formula, and we're going to be using it on our trinomials in the form of ax squared plus bx plus c, which is standard form. So when do we use the quadratic formula? We use it when we cannot factor using our traditional methods of common factoring, simple trinomial method, the Tuffy trinomial method, or the difference of squares. So when those methods do not work, we have a last resort, and we always keep it as a last resort because it is a little bit longer and complicated. So then finally we go to our last method, which is the quadratic formula. So here it is. It's written as x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. For every question, we always first do a test called the discriminant. And that test is just the part that is underneath the square root sign. So notice this part, b squared minus 4ac, without the square root. We just take that part, and that tells us how many roots there are. Now, what does that mean? It tells us how many answers we should expect to see. So if the result of b squared minus 4ac is greater than 0, that means if you get a positive answer, then we have two real roots or two x-intercepts. If b squared minus 4ac equals exactly 0, then we have two equal roots or one root, and that means we just have one x-intercept or one answer. If b squared minus 4ac is less than 0, which means gives us a negative answer, then we have no real roots. We have no answer. So what does that look like as a picture? Here's a parabola that does have two real roots. That's two x-intercepts right here, here and here. That means we would be able to find two answers. Here's a parabola that just has one x-intercept. So it's a parabola that sits on the x-axis, and notice it only touches the x-axis at one spot. So we would expect only to find one answer. Here's a parabola that has no x-intercepts, so we would not even be able to find an answer. It's a parabola that floats above, or it would be below the x-axis. Let's look at how we might use the quadratic formula to solve for the x-intercepts in this question. So notice here we have our normal equation, x squared minus 8x plus 2 equals 0. And first we need to always identify what is a, b, and c from the equation. So a is 1, that's the constants in front of the variables. So a is 1, our b is negative 8, and our c is 2. So let's do the discriminant or the test first, b squared minus 4ac. Once we've listed these numbers, these three are the only thing that we have to work with. So let's put those in. So notice that b is negative 8. That has to be in a bracket. B squared minus 4, it's always 4, times a, which is 1, and c, which is 2. Now when we put this in our calculator, let's see what the result is. The result is 56. We get a positive answer, and that means that we are going to have two real roots, or we should expect to find two answers. So since we do have two answers, we can go ahead and use the whole formula. So here it is. And now all we have to do is plug in the rest of our numbers. So it's negative b, and b is from above, plus or minus. Now, the square root of b squared minus 4ac we already calculated above, so that's nice. We've simplified one step. We'll put the 56 under here and put it under a square root sign, and then the whole thing is divided by 2 times a, and a is 1. So this is an important step to write. Fill in all the numbers. Now the next step is we break this down into two pieces because of the plus or minus. It's actually two equations. So we write them this way and this way. So what this says is 8 plus square root 56 divided by 2. That's one thing that this says. And the other thing that this says is 8 minus square root 56 divided by 2. So notice that we've tidied up the signs on the 8. The minus and the minus make a plus. Okay, so the two pieces are, one is a plus and one is a minus. And the last step, all you have to do is put this in your calculator and solve. So we get 7.7 and we get 0.3. Now notice the reason that we couldn't use one of our other methods from before on this question is because the roots are decimals. These are the x-intercepts. They are decimals, and the other methods only work when our x-intercepts are nice even numbers. So when we have decimal x-intercepts, they're too hard to find, and that's when the quadratic formula becomes helpful. Let's do one last question. So using the same process. Now the last one was a simple trinomial, and this one is a toughie. So our a is 3, our b is 1, and our c is -2. We're just going to write do our test, and so we have b squared minus 4 times a is 3 and c is -2. The result of that again is positive 23, so that means we do have two real roots. Now, if this was one real root, you would still go ahead and do the question. You would only get one x-intercept. If this was a negative answer, then we would write therefore no roots, and we would not proceed any further because there would not be anything to find. But in this case, we can go ahead. Let's write out our quadratic formula, and let's fill in the numbers from above. So we have negative b plus or minus the square root of our b squared minus 4ac gave us 23, so we can put that under the square root, and it's 2 times a, and a is 3. And we'll do the same procedure. Let's tidy this up and break it down into two pieces, one being a plus, the next being a minus. So we have -1 plus square root 23 divided by 6, and we have -1 minus square root 23 divided by 6. So put these both in your calculator, and be careful here when you do the top part. Hit the equal sign before you divide by 6. Otherwise, you may not get the right answer. So again here, when you do -1 minus square root 23 equals, get an answer, and then divide by 6. Sometimes the calculator doesn't do the appropriate BEDMAS. So we get 0.6 and we get -0.97. So normally rounding to 1 or 2 decimal places is okay. So check that you can actually get those answers in your calculator, and now you should be able to do questions using the quadratic formula to solve for roots, or in other words, find the x-intercepts of your parabola.